Tao, and I teach 5th grade math at A.L. Watts Elementary. I'm also a classroom demonstration teacher for the county. So today we're going to review 5th grade topic 2, which is operations with whole numbers and decimals. Okay, so what you can expect to review today is dividing whole numbers, multiplying decimals, and dividing decimals. You will have all of these in your packet. You will also need to do some subtraction and addition because that is how you do these 3 items. So our objective for today is to perform operations, so addition, subtraction, multiplication, and division with whole numbers and decimals to the hundredths or 2 decimal places. Okay? So before we get started on some examples, we're going to review some vocab. So partial quotients. You probably remember this from this year because you talked about partial quotients and you talked about partial products. And partial products has to do with multiplication. Partial quotients is what we use to divide multi-digit numbers. The quotients you get in each step are called partial quotients. Okay? So that example is shown down here in the orange. Okay? So we will show some examples in just a moment. Our area model for division is a rectangle, and it is used to solve division problems in which the quotient and divisor are the length and the width of the rectangle. So if you look at the colors down here, your divisor is on the outside, okay, and that is the number which another number is divided. Okay, so that goes on the outside of the house or on the outside of the box. Your dividend is the number that is divided by another number, and that's going to go on the inside of the house or inside of the box. Okay, and then our quotient is always our answer to our division problem. Okay, so let's look at dividing whole numbers. So in 5th grade, we touch on 2 strategies, which are the 2 we just talked about. Your teacher might have also shown you that standard algorithm. So that is what you are going to focus on once you get to 6th grade. But if you've already been exposed to it, that's great. We're just going to review the 2 main ones that we talk about in 5th grade. So both of these strategies use estimation to solve. Okay, and that's going to lead you into a true mastery of that standard algorithm. So, I'm going to show a video that I did of 540 divided by 12. So, before I start, I do want to tell you that something I always tell my classes are you need to always start with a factor that you know. Okay, so a simple basic fact or a power of 10. So 10, 100, 1,000 if it's a very big dividend. Okay, that way you don't need to make it more complicated than it is. Okay, so let's see what I mean. So first I'm going to see how many times I think 12 can go into 540. So like I said, I'm going to start with a fact that I know. I know 12 times 10 is 120. I also know it's still kind of far away from 540, so I bet I could get closer. So I'm going to use my basic facts of 12 times 2, 12 times 3, and I'm going to use that to solve those multiples. Okay, so I'm noticing 12 times 30 is still pretty far at 360. 12 times 40 is 480. That's pretty close. So I'm going to try one more and see what happens. I do not want to go over that dividend. Okay, so, I noticed 12 times 50 is too big. So I'm going to mark that out, and I'm going to use 40 as my first partial quotient. I'm going to subtract 480. And I'm going to get 60. Okay, well, I just noticed that I used 12 times 50 equals 600. So I think that tells me that 12 times 5 could give me 60. So once I realized that, 5 is my next partial quotient. Okay, so I'm going to subtract 60. Okay, so I'm at 0. The ways you know you're done dividing are the number at the bottom is 0, or the number at the bottom is smaller than your divisor. Those are the ways you know that you're done dividing, and you can start piecing together your answer. Okay? So now I am using green to circle my partial quotients, and I'm going to add them together, and I get a quotient of 45. Okay? So the neat thing about these strategies is that if I'm solving with a friend, me and the friend might not get the same path to get there, but we're going to get the same answer. And what I mean by that is me and my friend may not have the same partial quotients. So, because you realized I used 12 times 40 as my first partial quotient, but I could have used 12 times 20 as my first partial quotient. So, let's look at the area model example. It's the same equation. So now you're going to see how I use different partial quotients, but I came up with the same answer in the end. Let's make this a little bigger here. There we go. Okay. Here we go. So I'm going to use a fact that I know, which is 10. So 12 times 10 is 120. I know it's probably going to take me a little bit longer to do this one. So I subtract, and then I'm going to move it up to that second column. So if you notice, it's pretty much the same steps as partial quotients. The area model is just more of a visual. Okay? Now, I know 12 times 2 is 24. So I know 12 times 20 has to give me 240. So I'm going to subtract, and I get 180. So now I'm going to start over, bring my 180 to that third column. Okay, now 12 times what can give me 180 or close to it? Now, I made a mistake here, and I'm going to realize it in just a second. Teachers are humans too, and we make mistakes. 1 minus 1 is not 1, Mrs. Towle. There we go. I figured it out. So that's very important too, that you're making sure that you are subtracting correctly, because that could mess up your equation. So I know 12 times 5 is 60. And then there again, we ended at 0, so I knew I was done. Now I'm adding all of the numbers that are lined across the top. So 10 plus 20 is 30, plus 10 is 40, plus 5 is 45. So it's so neat that I got the same answer on both problems, but the ways I got there were not the same. So that is the really cool thing about dividing and all the different ways that you can do it. Okay, so let's look at multiplying decimals. So multiplying decimals is very relevant to us because we use money, and we use money a lot as we get older. So this is super important for us to learn. Okay, so when you're multiplying decimals, it is very important that you keep in mind place value. Okay, because if you think back, when we learn to add and subtract decimals, we learn to line up the decimals, line up the place values, and drop down your decimal in the answer. It is not like that for multiplying decimals. It is very important that we think about place value. Okay, so we're going to first look at an example of multiplying a whole number by a decimal. Okay, so I first noticed that the first factor, 25 hundredths, is less than 1. That means that the product, or the answer, cannot be larger than the second factor. Okay, so what I mean is, tell me what 1 times 3 is. 3, right? Okay, if I'm multiplying something less than 1, I can't get an answer bigger than 3 because 1 times 3 is 3. So I know it has to be smaller than that factor. So hopefully that makes sense. So I'm going to think of basic facts first. Okay, so I'm going to ignore the decimal for a moment. Okay, 25 is always, once you get into money more, that's what I always think of. I always think of quarters with 25. Okay, so I'm going to take 25 times 3. I know 25 times 1, so 1 quarter is 25. 2 quarters is 50, and 3 quarters is 75. Okay, so 25 times 3 is 75. Well, I know now I have to think about my decimal. So what if I made it 2 5/10 times 3 equals 7 5/10? I know that can't be right, so I'm going to use that pattern to solve 25 hundredths times 3 because I have the digits 7 and 5. I know they're going to be the same. So if I have 25 hundredths times 3, 25 hundredths has 2 decimal places, okay? 3 has 0 decimal places. So I know my product has to have 2, okay? So 3 quarters, like I think of it, is 75 cents. Now let's swing back up here. Is 75 hundredths less than that second factor? It is, right? So I know that is totally reasonable answer because I am multiplying 3 by a number less than 1. Okay, now let's look at multiplying a decimal by a decimal. Okay, so 4/10 times 6/10. The answer to this is 24 hundredths. So I always tell my class when you multiply a tenth times a tenth, it gives you a hundredth. Okay, so 4/10 has 1 decimal place. 6/10 has 1 decimal place. So that's going to equal 2 decimal places in your product. Okay, so I have made a model over here. Okay, so let's look at, it's going, 6/10 is in the yellow. So I shaded 6 rods, 6 columns, which is also the same as 60 hundredths. Okay, so that's in yellow. I also shaded 4/10 or 40 hundredths in purple. Okay, so when you're looking at these, the area where they mesh, so the area where both colors overlap, or if you just have a pencil where you've shaded your pencil twice, that is your product. Okay, I know that my answer cannot be bigger than 6/10. Why do I know that? Well, remember over here we talked about if you multiply a number less than 1, it can't be bigger than that second factor. So 4/10 is definitely not larger than 1, so my answer has to be smaller, okay? So my answer is 24 out of 100. And you can also use that basic fact of 4 times 6 equals 24, okay? And think about what would be reasonable as far as where my decimal could be placed, okay? So let's go to dividing decimals. So when you are dividing decimals, there are some things to remember. When the divisor is greater than 1, the quotient is less than the dividend. Okay, so that's a lot of words, so it might be confusing, but we'll talk about it. So I've matched the purple with the purple box down here for an example, and then the orange text with the orange box. Okay, so when the divisor is less than 1, the quotient is greater than the dividend. Okay, so you can use multiplication to solve a division problem. And this works because multiplication and division are inverse operations. What does inverse mean? Do you guys remember? It means opposite, right? So, to find 4/10 divided by 5, we're going to think, okay, 5 times what could give me 4/10? So we're going to break that 4/10 down, and we're going to think about it as 40 hundredths. You're probably thinking, how is it 40 hundredths? Okay, go back to when you all use manipulatives, okay, or hundredths grids, okay? 4 rods which are the tall ones that have 10 in them each, right? 4 of those means you have, one has 10 in it, right? So 10 hundredths, okay? 20 hundredths is 2 tenths. 3 tenths is going to be 30 hundredths. And 4 tenths is going to be 40 hundredths. So we're going to think of that as 40 hundredths. So 5 times how many hundredths gives me 40 hundredths? Well, think of just the basic fact. 5 times what gives me 40? Okay, I know 5 times 5, 5 times 6, 5 times 8 is 40, right? But I know my answer, okay, has to be less than 4 tenths, okay? So my answer has to be smaller, which gives me 8 hundredths. So this is how I tell my students. I think of it as brownies, okay? I have a 4 tenths pan of brownies left, and I'm going to split it between 5 friends. Am I going to be able to give away more than 4 tenths of a pan? No. So my answer has to be smaller than what I started with, because I don't have that much to give away, right? Okay, so let's think of it the other way. Let's think of if the divisor is less than 1, the quotient is greater than the dividend. Okay, so 6 divided by 3 tenths. Okay, my dividend is 6, so it's a whole number, and my divisor is less than 1. So think of 3 tenths times what gives me 6. So let's go back to that thinking of turning 6 into something else. Okay, so I'm going to make 6 into tenths because that's what the 3 is. Okay, so 6 equals 60 tenths. So 3 tenths times what equals 60 tenths? Okay, well I know 3 times 2 is 6. So could I say that 3 times 20 is 60? Yeah. So 3 tenths times 20 equals 60. So that means that 6 divided by 3 tenths equals 20. Okay, let's look at one more example. Okay, so this is if you're gonna set up your division problem and use partial quotients. Okay, so 18 divided by 75 hundredths. So we're gonna change that 18 into hundredths because that is what our other factor or our divisor is in. Okay, so 18. The 8 is in the ones place, right? Okay, so, and the 10 is in the hundredths place, correct? Okay, so that's going to turn into 1,800 hundredths. Okay, so that's going to be my dividend, and then my divisor is 75 hundredths. So since I changed 18 ones into 1,800 hundredths, I do not have to put a decimal down here in my equation, okay? So now I'm going to think back about when we just talked about dividing whole numbers, and I'm going to use that same strategy. So 75 times 20 is going to give me 1,500. If I subtract, I get 300. 75 times 2 gives me 150. I'm going to subtract, get 150, and then I know 75 times 2 gives me 150. So I'm going to take all my numbers at the top, all those partial quotients, and I'm going to add them together to get 24. Okay, so I hope that was a nice little refresher on what we learned this year. Okay, in your packet there are also some examples. So if this wasn't enough, then you can look in your packet, and there are some examples. There are visual examples, so they have some models and some equations, okay? Okay, so something fun that you guys can do at home now that we've reviewed the harder stuff is this little brain buster. So you can do it with a friend, you can do it with a family member, you can do it by yourself. I first saw this when a student did this to me a few years ago. So you're going to first think of any number. Okay, so any number. You're going to subtract 1 from that number. Then you're going to multiply it by 3. Add 12. So you're keeping a running total. Okay. Then you're going to divide that number by 3. You're going to add 5. And then you're going to subtract the original number you had thought of from that answer. Okay, and you should get a final answer of 8. So this is just something fun you guys can do to lighten the workload. I hope you guys have an amazing summer. Keep doing math, and we can't wait to see you guys.